All right, so we are continuing our notes over 2.61 Part 4, related rates. What we're talking about in this section, again, is that we are trying to find maybe the rate of change of an angle, such as here. We might want to know how fast is this angle changing. If we want to know how fast the sides are changing, and it doesn't involve the angle, we would want to use the Pythagorean Theorem and related rates. But anytime we need to know at what rate is that angle changing, we have to use sine, cosine, tangent, one of those trig identities. We also talked about the volume of a cone formula.
Jasmine Smith.
That's given right here.
To the front of the building to meet your ride.
All right.
Jasmine Smith.
So let's look at number 2. So a television camera at ground level is filming the liftoff of a space shuttle that is rising vertically. The camera is 2,000 feet from the launch pad. Find the rate of change in the angle of elevation of the camera when the space shuttle is 5,000 feet off the ground and is rising at a rate of 1,000 feet per second. Okay, so we need to figure out a picture here for this. A television camera at ground level. So here's our television camera, I don't know, whatever that looks like. It's at ground level. Is filming the liftoff of a space shuttle that is rising vertically. So here might be our space shuttle. There's our rocket or whatever it is. So the camera, here's the camera, is 2,000 feet from the launch pad. Well, here would be the launch pad. There's where it's launching up from. So the camera is 2,000 feet from that. Okay, let's keep reading. When you're doing these problems, you always want to read the whole problem and then go back and take it one sentence at a time. So find the rate of change in the angle of elevation. Right here we see angle of elevation, rate of change of the angle. That means I'm going to have to use sine, cosine, or tangent and related rates. When the space shuttle is 5,000 feet off the ground, so this is 5,000, and is rising at a rate of 1,000 feet per second. Well, if I'm going to call this my x, and this my y, and this my h for hypotenuse, how fast this is going off the ground, that's going to be dy dt, and that is 1,000 feet per second. So the question is asking us to find d theta dt, find the rate of change of this angle of elevation. So what I want to do is I want to look at what I'm given. I don't want to use something that I'm not given. For example, I'm not given any information about this. I don't know how fast this side is changing. I don't know the length of it. I may have to find out some of that, but I prefer not to find things that I don't have to find. So because I'm given y over x, we have to think what's the trig function that uses y over x, and that trig function is tangent. So I'm going to start off by saying tan theta has to equal y over x. Because this is a quotient, I'm going to have to use the quotient rule when I get over here. But for now, the derivative of tangent theta is going to be secant squared theta, d theta dt. The derivative here, I do derivative of the top, that's dy dt, times g minus f, g prime is dx dt, all over the denominator squared. So here's my problem. I'm going to check it out and see what it is that I know and what I have to find. So I'm trying to find d theta dt. I have to know everything else. So looking at this problem, dy dt we know, x we know. See, this is x, this is y. So I know x, I know dy dt, I know y. I do not know dx dt right now, but think about it. How fast is this side changing? The camera's right here, the launch pad's right here. Neither of those two is moving. It's not like the camera's moving away, the launch pad isn't changing. So we should know dx dt is 0. So I know dx dt. So now I know this, that. I need to know the secant. Well, you got to think back to SOHCAHTOA. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So I need to do my h over my x. So I have to find out what this is. I'm going to have to go ahead and use the Pythagorean theorem to find that. Now, I don't really want to have to do 2,000 squared plus 5,000 squared. So here's what I can do. I can do 2 squared plus 5 squared equals c squared, or h squared in our case. 4 plus 25 equals c squared. So c is going to be the square root of 29. But I had divided these by 1,000, so I'm going to have to multiply this by 1,000. So this is 1,000 radical 29 is its length. When I go to find my secant, secant is going to be hypotenuse over adjacent, or h over x. So it's radical 29 over 2. I'm going to reduce that ratio. Radical 29 over 2 is going to be my secant. I have to square that, and that's going to allow me to find d theta dt. dy dt was 1,000. X was 2,000. Y was 5,000, but dx dt is 0, so I'm not going to bother with that. X squared, well, if I square 2,000, that's going to be 4 million, twice as many zeros. So here's what I've got. I've got 29 over 4 d theta dt is equal to 2 million over 4 million. Of course, that's going to reduce down to 1/2. So now to solve for d theta dt, I'm going to multiply by the reciprocal, 4 over 29. So d theta dt, which you can also call that theta prime if you want at this point, that's going to be 2 over 29. And we measure degrees, or I'm sorry, angles are measured in either degrees or radians. And in this case, it would have to be in radians. So it's going to be 2 over 29 radians per, let's see the units, seconds. So that's going to be the rate of change of our angle of elevation. Of course, we could use a calculator if we wanted that as a decimal. All right, number 4. A cone has a diameter of 20 inches when the height is 30 inches. Find the rate of change of the volume of a cone if dr dt is 2 inches per minute when the radius is 6 inches. And it gives us a hint that similar triangles are formed. May or may not need that. All right, so I'm going to look back up at the top and look at my formula for this. So I've got dv dt. You can also call that v prime if you want. We know we're taking the derivative with respect to time. Is 2/3 pi r h dr dt. I don't like to call it r prime here because I'm afraid I'm going to think it's just an r and not dr dt. So I like to make it obvious. 1/3 pi r squared dh dt. All right, so let's see what we've got. We are trying to find the rate of change of the volume. Okay, so this is what I'm solving for. So I'm going to substitute in everything I can. Now, it's asking us to find the rate of change of the volume when the radius is 6 inches. Okay, so here's our cone. So what they're telling us here is that maybe here at the very top, when the diameter is 20 inches, the height is 30 inches. So that means the radius is going to have to be 10 inches, and the height is 30 inches. Well, those similar triangles are formed throughout the entire cone as it leaks the liquid, whatever it might be. Maybe there's a hole here. Okay, so I can see this relationship then. The height is going to be 3 times the radius. So the other thing this tells me then is that if I take this derivative with respect to time, dh dt is always going to have to be 3 dr dt too. So that piece of information there, this first sentence, that gives us a lot of important information. It's telling us this, and it's telling us this. Both of those are very helpful. So now let's see what we can do. Find the rate of change of the volume of the cone if dr dt is 2. So I'm going to plug in 2 for dr dt. What is the radius when the radius is 6 inches rather? So I know the radius has to be 6. Well, I also know the height has to be 3 times the radius. So when the radius is 6, H is going to have to be 18. So 18 for the height. All right, over here then, I've got 1/3 pi. Radius is 6. 6 squared is 36. Now I have to also know this. Well, maybe you think, we don't know that. But we know that dH dt has to be 3 times whatever dr dt is. They tell us that dr dt is 2. So therefore dH dt is going to have to be 3 times 2, just substituting that in. So it's going to have to be 6. And now it's just a matter of figuring this all out. So I can do this. 6 divided by 3 is 2. 18 times 2, that's 36, times another 2 is 72, times another 2 is 144 pi. Plus, you can divide those, or those, whichever I prefer. 36 times 2 is 72 pi. So the rate of change of our volume is going to be those two added, which is going to be 216 pi. And that's going to be measured in, got to make sure all these units are alike too, inches, okay, inches per minute. And there we go. So in this case, because this rate of change is positive, that means that this had to be getting filled up with a liquid. So maybe this was like a conical shaped cup that we're drinking out of or something. So they would be pouring liquid in since the rate of change of the radius is getting larger. If the rate of change had been negative, that would mean that the liquid is coming out of the bottom. Maybe there's a little hole there and the liquid's coming out. But that would be if that had been a negative, or if they said that was decreasing at that amount. Okay? All right. Hope that makes sense to you. You'll be finishing the worksheet that you have. Actually, you're going to do worksheet number 2 on related rates.